have some time for some questions, but we did have one question come to Guy previously that just talked about the amount of steel used to produce the SPS and how that compared to rebar or concrete reinforcement within a flooring system.
Does that have a question related to do it with sustainability?
I can't really tell. It's just how much steel is used to produce the SPS panel when comparing to reinforced concrete floor for the same floor loading.
More rebar. I don't know the exact numbers. It's never a question I've looked at. But if it is to do with sustainability, which may be the reason, what we've found is that we have more carbon content than a concrete floor per se, per unit, per nominal unit. Once we get to the bottom of a building and accounted for the weight that we've taken out, we have a carbon saving or an energy saving or a total embedded material saving. For some reason it's actually more in stadium, but and I think that is a reflection that as the nature of the demanding nature of the structure goes up, then perhaps greater benefit comes through using lighter technologies.
Okay. And a question for Russ is, do designers take enough account of local conditions and culture, or are they guilty of trying to impose global and foreign concepts and solutions which might not be appropriate?
Certainly what we see with designers is more of a desire, it's really more of a desire to be creative. And I think that what we're seeing and what we saw certainly in the presentations today and others, that this creativity is taking a flavor and certainly a very large input from the local communities. So I really feel that all of that can be met and do it in a very effective way.
Okay, thank you. So, another question? Okay.
Question for Russ. Russ, would you give us some insight into your future research, into research that's happening now for future products in your line of business?
It's a great question, and we have been a leader in bringing new products and doing a great deal of research to bring products to the marketplace. Some of the things that we have looked at, as I alluded to in the presentation, was building integrated photovoltaics, but it has such severe limitations we've not been able to make it pencil. What we have learned from that, though, is that the harvesting of light is so much better, so the development of interior light shelves is a way to move light in. We use nanotechnology today to create thin films that provide filters to undesired and desired energy transfer through glass. We're looking at some of the same kinds of technology to redirect light so that as the sun's light comes through a window, it streams in and immediately goes to the floor where it turns into heat as soon as it strikes anything. Can we use nanotechnology to bend that light and send it deeper into buildings? So that's one of the things that we're looking at. We continue to look for ways and evaluate other technologies that allow one to be more creative. I think that, we've approached in our nanotechnology some of the limits of physics in terms of filtering different wavelengths of electromagnetic energy. What we need to do today is to be more creative in our designs. Typically, to make a building more energy efficient, you had to make it mirrored or darker. People don't like mirrored or darker, so we need to find ways to do that, and we're working on some of those kinds of ways to make the buildings have a different appearance to them, but still do the job of filtering the unwanted energy and allowing the wanted energy to go through.
Okay, thank you. Question up here.
I am a student at the University of Illinois at Urbana-Champaign. My question is for Guy about how do you compare concrete slab with your SPS in terms of vibration and also protection against fire?
Thank you. The dynamics or vibration of the floor plate is designed to deliver the same performance, whether it be for a bridge deck or for an office floor or for a residential floor. We don't have the weight of concrete, so we have to use the stiffness of the material. So as a metric, concrete might typically have a stiffness under static load of L over 360. We're probably operating in the region of L over 700. So instead of weight, we use stiffness, but we deliver the same dynamic response or acceleration as concrete. On the fire question, in the maritime industry, the plate itself, the composite plate, is used as a 60-minute fire barrier. It uses the polyurethane to achieve this. In tall buildings, we need to achieve 2 hours, in some instances 3 hours. We found the most cost-effective way to do that is to put fireboard or cementitious spray underneath it. This also allows two valuable points in introducing a new technology. There's probably some very clever ways of protecting the bolts that we use and stopping the passage of heat through the floor, but the simple way is to spray everything. So I'm sure in the future somebody will develop a clever way of just doing the bolts. So simplicity and ease of use is a driver there. The other driver is fire marshals, the local fire official that says the building will work. Being introduced to a completely new technology and doing it a different way may trip over. Whereas if he sees a product that is protected with conventional material, then on day one, on the first buildings in that particular zone, they will feel comfortable. I know, for example, that Heathrow Airport is already looking at removing that requirement because they feel that they are an intelligent customer that can make that choice. So today we protect it with fireboard or cementitious spray. I think in the future we will reduce the amount of that is used through innovation amongst this community.
Next question.
Yes, this question is for Guy again. Thank you very much. My question is, have you looked at possibilities of curved surfaces? That's one question. And the second one is for R value for using it on the exterior surfaces. Thank you.
Thank you. Yes, we have looked at using it for curved surfaces. The ship's hulls, it's an unavoidable requirement. It can be done, but it does cost more. What we actually do is we curve both plates and then we inject the way we make SPS is to take two steel plates and inject a liquid between them. The liquid cures and glues to both paste plates. There's no adhesive between the three layers. So if you've got a curved surface or a complicated surface, or a surface that in plan has holes and curves, we just inject in between it. So curving can be done. Your other question was about R value. We do have some insulation, but we are not as good as a foam product. The material in the middle is very solid, so while it provides actually very good fire protection, over time, associated with insulation for thermal, it is a solid and it will let through a degree of heat, and therefore you typically have to have the same finishes on it that you might have in a thin concrete layer.
Another question up here?
Hi, Zach Costura with the CTBUH and a structural engineer. I'd like to get some insight from the speakers on challenges you face of introducing your products into urban areas where you have to get approval by the buildings department and where that approval process is influenced by building trades that already exist there.
I'll tackle it first. Certainly the most common restriction we have in new products or our products in urban areas are to meet energy requirements. I love to tell the story about the buildings that have gone up to replace the World Trade Centers. Manhattan has a very limited supply of electricity, so they're very conscious and enforce their codes and standards. And so we worked with the architects on these World Trade Center buildings that are going up to be very creative in terms of providing the kinds of optics that were desired, but yet getting to the energy efficiency that were necessary to meet the codes and standards. I think that these agencies are very appropriate in what they're looking for, and I think that when we work together with the designers, we're able to do that. In those specific instances, we did that with silk screening. Silk screening is a wonderful way to mitigate solar heat gain without making the building dark or mirrored. And we're very creative in the designs and the application of these, combining them with the nanotechnologies of thin film coatings to provide the right filters. So we're comfortable in that area.
Yeah, I would second that. I'd add that the way you work with code and the regulators is it's an engineered product, in my instance, I'm sure, with Russ's instances. Therefore, it's just a load of facts. There's no hypothesis here, it's facts. So, first thing you do is you give them every single fact they could ever want. The second thing you do is give them as much time as they need and as much of your time as they need to go through the journey of understanding a new technology. The last thing that we've had to do is sometimes look at the intent of the code and to question the specific word against what was intended. Because sometimes you'll find in introducing something new that the code has been written assuming in the back of somebody's mind that it was going to look like this, and you're putting something that looks different. I find, and I think we find that most code officials, if you engage them in that conversation, are very open to that conversation, so long as they don't feel under time pressure.
Any other questions?
This is Mir Ali with the School of Architecture, University of Illinois at Urbana-Champaign. I think my comments and questions are for Guy. I think I'm a bit premature in making my comments because I don't know the subject well, and also maybe I'm thinking a bit loud, but let me ask you anyway. I see some great potential for this material for tall buildings, very tall buildings, because it will reduce the weight of the structure and all that. Also, the floor systems where we use trusses and beams, we need deeper beams and deeper trusses, and that takes up some of the floor height. And because of that, we need more cladding in the structure. And also, we lose energy because there is more volume to be heated or cooled of air. So if these plates can be somehow made into beams or something like that, this could be pretty shallow because the strength is tremendous. You have demonstrated with those big pieces of rock. So I see some possibility there. Maybe you can clarify a little more. But I am a bit concerned about one thing, which is the overturning of the structure. Because the material is very light, when the building is tall and slender, then it will tend to overturn under wind or even seismic, depending, what nature of seismic we have. Now you can, of course, place the shear walls or core walls and everything there to stiffen the structure laterally. But those shear walls and core walls have to be also stabilized with weight to keep them stable. So I think that is one concern of mine. And the other thing is the cost of this as compared to steel or concrete. Can you give some? I think I have asked you too many things, but
I think you asked three questions. So I'll try and answer them in the order you asked them. The first one is, can we do different ways of using SPS than a simple flat plate sitting on a beam? Yes. We have them in our back pocket. We built a mobile bridge for the German military a few years ago, which is 6 inches deep. I don't know why the German military wants a mobile bridge, but it's a separate issue. There are several different ways of using the material that are out there and give different configurations of the material, both for a horizontal structure and a vertical structure. We have to start somewhere, and we have to make first thing work. We also have to make that thing as easy to adopt in the industry as possible. So we have these sort of Mark II, Mark III, Mark IV ideas up our sleeve, but we thought it was important to start with something that was as easy to integrate into existing structures as possible. Your second question was to do with weight and overturning moment. Yes, you need weight, but there are other ways of achieving structural strength and resistance to a wind load. So, yes, we are removing weight, and yes, that will mean structures resisting the wind load have to be used differently. But for the wind load, people that we've spoken to so far say that is achievable. And for the seismic, which is not the wind load, for the seismic load, this is actually, the weight saving is actually seen as a significant advantage. On cost, the cost work is available on our website. We're more expensive than concrete. Actually, our terracing product, our stadium product, is cheaper than concrete, but our flooring product is more expensive than concrete per unit square foot. The end of a building, so once all the bills have been paid, what you've paid for the materials is cheaper. And you then get, on top of that, the benefit of time. And that, I believe, is the reason that Peter Rogers and others are pursuing this technology.
Yeah, I think about the overturning, your answer was not fully satisfactory because you didn't say specifically what you will do. You said we can do. So I'm not still fully convinced about that. For seismic, yes, because we are dealing with lighter materials, it will attract less force, inertia force. I see advantage there, but in terms of overturning, I don't know exactly what you will be doing to increase the weight. You have to spell that out a little bit more.
I don't. The beauty of what we're trying to do is not to be the designer of the world's tallest buildings. What we do is we work with people, and at some point in time I can say I don't know the full details of how they're going to do it. But in developing this product, that point was raised, and the engineers that we've been working with saying the benefit allows people to rethink the structures and deliver the stiffness in a different manner.
Thank you.
Okay. We're going to have one last question here. I see we've got two active individuals. So the man from Manila.
Yeah, we're Guy Turner. With climate change, rising water tides, a lot of cities being flooded, would you consider floating islands or floating houses? I think there's a possibility there.
I might deflect that to CTBUH Shipbuilding, who's our global joint venture in shipbuilding and maritime activities. The reason we won the Western project was because they were attracted by our heritage in maritime structures and the ability to resist the Atlantic Ocean as the primary structural barrier underneath that amusement arcade. So I hope that that amusement arcade never floats, but I'm sure the opportunity exists.
Okay, if you have some other questions, I'll ask that you talk to our panelists at lunch. And just a couple of items. Lunch is going to be in the same venue as it was yesterday. And lunch today is sponsored by SPS Floors. The ballroom directly to the south, directly outside the auditorium, and it will have two entrances, and the one to the north behind us will have one single entrance. You've got to make sure you hand over your day to lunch ticket to the people at the entry. So we will reconvene promptly at 1:45, and please give our panelists a great hand for great presentations. Thank you.